brief video shows you how to set up complex systems like electromechanical, electromedical testing machines, and so on to obtain high performances at low cost. A typical structure is composed of a PC, CPU, and FPGA control logic board, such as drivers and conversation boards, motors, sensors, CCDs, ADs, etc. Cost and performances dramatically change depending on where we place the control board. The first solution, the most intuitive, is to place it into the PC. The software development is simple, but we let into the PC the connection, isolation, and EMI issues. In the hardware, we have to add many drivers, receivers, EMI filters, high-density connectors with expensive and bulky cables. This solution is old and very expensive. Second solution. We place the control logic into the system. This can talk with the PC without adding a microcontroller and a standard interface. This solution is not that bad, but the software becomes complicated since it is split on two different CPUs. This means that we get high cost and low performances. Outdated and expensive solution which can be improved by placing all the control logic into an FPGA provided with a microcontroller. Third solution. Let's replace the integrated CPU with a single board computer. We have to add a PCI bus control board. This way, the external PC becomes optional and the software is simplified. As usual, the PCI control board shows the typical problems of a master-target interface, the cost of the IP, the high number of pins. We can improve it further. Let's move on to PCI Express in a mini layout. No IP costs more performance than PCI. Only 4 pins used on the FPGA. Good solution with low cost and high performances. The machine of today. Let's think at the machine of tomorrow. We want more performances, cost reduction. We want to replace the PC for fulfilling the request of the client or to support new interfaces. Could we? Yes, of course we can. We can place kind of PC, making it external to the machine. We can have the control board in the machine, so without any external cabling, but it will still seen by the software as on the local bus of the PC, thus reducing the complexity of the software. The connection is made by means of the PCI Express over cable standard. An upstream board available in any format is inserted on the PC and then connected to the FPGA machine control board by means of a single standard cable. Excellent solution, cheap, performant, the machine of tomorrow. The choice is up to you. You can spend your money to make something which is unmarketable today and beat the competition with winning cheap and performant choices.